tan x graph or tan x function. Let us consider tan x function. It is the function. This is the function. Next, actual domain, and this is the range. So function is tan x function. Next, actual domain. Actually, tan x is equal to, it is sine divided by cos. So cos x should not be equal to 0. Actually, what is the general solution of the equation cos x equal to 0? Already we did know x equal to 2n plus 1 means odd multiples of pi by 2, comma n belongs to z. So therefore, tan x means it is sine by cos. So it will take any real number except the odd multiples of pi by 2. This is actual domain, whereas n belongs to z. It is to be understood. Next, range. Here range means it is a real number set. Once again, same discussion. In this area, tan x is not bijective function. So therefore, simply we are considering principal value branch. What is the principal value branch? Open interval of minus pi by 2 comma open interval. No confusion. Actually, sin x is bijective in which area? Closed interval of minus pi by 2 comma plus pi by 2. It is closed about sin x. But here tan x, it is open interval of minus pi by 2 comma plus pi by 2. Now in this area tan x is bijective. This area is called principal value branch or bijective area or invertible area. Okay. In this area tan x is bijective. Of course, so many infinite areas are there, like that sin x and cos x. Okay. In this area tan x is bijective. So therefore, in this area it has inverse, means tan inverse. It is denoted by either tan inverse x or arc tan x. So therefore function. Next, restricted area or interval. Next, range. So function tan x, restricted area or bijective area, open interval of minus pi by 2 to plus pi by 2. Range is capital R. So therefore, even though this is actual domain of tan x, but in entire this domain it is not bijective. Therefore, the restricted area in this open interval of minus pi by 2 plus pi by 2, tan x is a bijective. Range is the same. So therefore, in this area it is bijective. Therefore, its inverse exists. Its inverse is denoted by sin inverse x or arc tan x. Tan inverse x or arc tan x. It is a definition. So therefore function tan inverse x, this is the function, and domain means R. Next, range is open interval of minus pi by 2 comma plus pi by 2 for tan inverse x. So therefore if tan inverse of x, that is equal to theta comma x belongs to capital R, x means domain, then by implies x equal to tan theta. Of course, theta must be belongs to open interval of minus pi by 2 to plus pi by 2. This is the definition of tan inverse x. Similarly means some explanation about this equation. Tan inverse of x means what? Any real number. So you can take 2. Tan inverse of 2 is equal to theta. Then we can write 2 is equal to tan theta. Of course, solution is there. for tan. Okay, we can write like that. Next, one standard formula. What is that? Tan inverse of x must be equal to x. It is true for all x belongs to capital R. Means some example. Tan inverse of 100. It can be written as 100. No problem. It is x belongs to, means for any real number we can write like that. Next, another formula. Tan inverse of tan theta, means for this statement no failure case, because we can take any real number. Okay, tan inverse of tan theta is equal to theta. So comma theta must belongs to open interval of minus pi by 2 to plus pi by 2. So we can show one failure case for this statement. Means tan inverse of tan for example pi by 2 90, means pi, we can write pi. It is not equals to pi, because pi it is not belongs to open interval of minus pi by 2 to plus pi by 2. Okay, next similarly tan inverse of tan of say one number in this interval, for example 60 degrees. 60 degrees means what? Pi by 3. It can be written as only pi by 3, because pi by 3 is belongs to open interval of minus 90 to plus 90. Okay, another meaning, tan inverse of x means that it is arc tan. We can write simply like that. Next, but tan inverse of x not at all equals to tan x whole power minus 1. Similarly, we showed for other powers in sin x and cos x like that. In the same sense, it is applicable for tan also. So tan inverse of x means r 1 by tan means cot x, or it is cot x. Similarly, tan inverse of x1 is equal to tan inverse of x2, that implies x1 is equal to x2, because in this area only tan inverse of x1 means according to this, because tan inverse whenever in this area means in which area tan x is bijective, means in this area. So therefore in this area tan inverse x is also bijective. Therefore it is possible to say like that. This is about the tan inverse function. Another function, cot x. F of x equal to, let us take cot x function. Cot x means it is cos x divided by sin x. So therefore, whereas sin x not equals to 0, means what? It is the function. Next domain, next range. Function is what? Cot x. It is actual domain. Actual domain is capital R minus sin x equal to 0. Sin x, what is the general solution of sin x equal to 0? X equal to n pi, comma n belongs to z integer. So it is n pi, comma n, that is belongs to z. Range is what? Capital R. This is the range. Capital R. So similarly, the discussion like that sin, cos, tan, in this area cot x is not bijective. So therefore for all x belongs to capital R minus n pi, n belongs to z, f of x that is equal to cot x is not bijective function, So what will be the principal branch or restricted area? Open interval of 0 to pi. So therefore for all x belongs to open interval of 0, pi only, f of x is equal to cortex is bijective. You can refer the graph. Already I showed sine cos just like that. You must understand just like that sine cos. So that's why sine cos tan cot secant cosecant. It is better to read all the 6 graphs. Okay. So in this area cortex is bijective. So therefore f from open interval of 0 to pi to capital R, comma f of x is equal to cortex function is bijective. So therefore it has its inverse. Its inverse is capital R to open interval of 0 comma pi, comma it is defined as f inverse of x, that is equal to cot inverse of x, or arc arc cortex is also bijective. This is the simple definition of cot inverse x. So therefore if cot inverse of x is equal to theta, then that by implies the x equal to cot theta, whereas x belongs to here R, capital R, and similarly theta must belongs to open interval of 0 comma pi. Similarly we have the routine formulae like that cot inverse of x is equal to x belongs to capital R, means capital, for all x belongs to capital. X is what? The domain of cot inverse x. Of course the domain of f inverse R to open interval of 0 comma pi. So next similarly cot inverse of cot theta, that is equal to theta must be in open interval of 0 comma pi, Once again, in this actual area, cortex is not bijective. So the restricted area 0 to pi. In this area only cortex is bijective. So therefore in this area it has its inverse, f inverse of reverse R to 0 to pi. Means what? It is bijective area or principal value branch. Thus f inverse x equal to cot inverse x or R to cot x. Of course this in this area f is bijective, therefore f inverse is also bijective. Okay, cot inverse of x is equal to theta, that by implies x equal to cot theta. Subject to the conditions, we can go through this to that to this, like that. Okay, routine formulae: cot inverse of x equal to x for all x belongs to capital R. No restriction, we can take any real number. Next, cot inverse of cot theta equal to theta, but theta must be in open interval of 0 comma pi. For example, failure case, cot inverse of cot of. So we can take, tell me one value of theta beyond open interval of 0 comma pi, means 270, means 3 pi by 2. For example, 3 pi by 2. So it is not at all equals to 3 pi by 2, even if it is in this form, because this 3 pi by 2, it is not belongs to open interval of 0 comma pi. Similarly, cot inverse of x1 equal to cot inverse of x2, that implies x1 equal to x2, because cot inverse is also bijective function. This is all about cot inverse x. Let us take f of x equal to secant x. So function actual domain next range function secant x. First we will talk about natural function secant x. Actual domain, actually secant means it is 1 by cos x. That's why the domain will be capital R minus odd multiples of pi by 2. That's why it is better to practice first actual domains of all trigonometric functions. Next range, no confusion. You come here, come here. It is reciprocal of cos x. What is cos x? Cos x range. This is 0. It will be -1. It will be +1. So this area, it is cos x. The range of cos x is closed interval of -1 comma +1. What is its reciprocal area? Total this area. It is about secant x. Understand like that. That's why secant x is less than or equal to -1 union secant x is greater than or equals to 1. Means what? That is come here. That is open interval of -infinity means -infinity comma -1 closed union closed 1 to plus infinity. Simply we can write capital R minus open interval of -1 comma 1. Means what? This is real number line 0. This is +1. This is -1. Total R minus. Actually here we are considering -1 and +1 also. Therefore we are writing open interval of like that. Open interval of total area except open interval of -1 comma +1, because already in our required area -1 is included, +1 is included. That's why in this form it is excluded. Remember, later further we are writing or we are using simple form capital R minus open interval of -1 comma 1, or another notation is there. Capital R means open interval of -infinity comma infinity minus open interval of -1 comma 1. We can write like that. Hence the range of secant x. This is the range. It is a capital R, real number set, minus open interval of -1. As usually in this entire actual domain, secant x is not bijective. Therefore secant x will be bijective in just like cos. Cos is what? Closed interval of 0 to pi. But pi by 2 is in this interval. But if x equal to pi by 2, total this function is not defined. Secant pi by 2 means 1 by cos pi by 2. Cos pi by 2 0. 1 by 0 infinity. Not defined. That's why it is excluded. Pi by 2 is excluded. So in this area sin x is bijective. Of course, so many infinity areas are there. Gradually I am telling for every trigonometric function, sin, cos, tan, cot, just like that. Secant also, so many infinity areas are there, so that the secant x is bijective. But it is called principal value branch, PVB. So therefore f from PVB, closed interval of 0 comma pi, except pi by 2 to pi by 2, range is the same. Capital R minus open interval of -1 comma 1. Why the range is the same? Because in this area it is onto function. For onto function, codomain and range will be the same. Like that, f of capital A is equal to capital B. So since f is a bijective, means what? Already it is onto function. That's why in actual range, this range will be the same in each and every case. Sin, cos, tan, cot, secant, cosecant, like that. Okay, it is a bijective. Is bijective function. Therefore, its inverse, f inverse exists and defined as, here bijective means f of x is equal to secant x. Okay, its inverse is capital R minus open interval of -1 comma +1, means range becomes domain, domain becomes range for inverse function. Closed interval of 0, pi minus the set of pi by 2. Of course, it is also bijective. It is also bijective, comma f inverse of x equal to secant inverse of x is also, it is also bijective. So therefore, in this area, its inverse is exists. This is the notation and definition. Similarly, secant inverse of x equal to theta, that by implies the x equal to, we can write secant theta. For all its domain, x belongs to the domain of secant inverse x means capital R minus open interval of minus 1, 1. Of course, theta belongs to same closed interval of 0 pi minus pi by 2 singleton set, the set of pi by 2. Okay, as usually secant inverse of x is equal to x for all x belongs to, x means capital R minus open interval of minus 1, 1 means what? Everywhere in real line or on the real line, minus 1 to plus 1 means except this minus 1 to open interval of, so it is exempted area, open interval of minus 1 to plus 1. So x is where? X is here. X is where? X is here. This is x area, except this area. Similarly, secant inverse of secant theta, that is equal to theta. For all theta belongs to this one. Open interval of 0 to pi except pi by 2. Remaining as usually we can define the formula for secant x also. Secant x is function f of x equal to, let us consider cosecant x. Okay. Function, this is the function. Next, actual domain, it is actual domain, and this is the range. This is the range. Function cosecant x, this is the cosecant x, actual domain. Actually, cosecant means 1 by sin x. So its domain is equal to r minus set of n pi, so that n belongs to z, integer. Next, cosecant. Similarly, cosecant means sine. What is the range of sine? It is 0, it is minus 1, this is a plus 1. So in this area means this is the range of sin x. This is the range of sin x. What is its reciprocal? Cosecant x. So this is total cosecant x area. Cosecant x means cosecant x range. So therefore, cosecant x less than or equal to minus 1 and cosecant x is greater than or equal to plus 1. So therefore, total cosecant x must be belongs to open interval of minus infinity to minus 1 closed, means this area union 1 to plus infinity, or simply we can write r minus open interval of minus 1, 1. So therefore, the range is capital R minus open interval of minus 1, plus 1. So similarly, total entire in this area, cosecant x is not bijective. Therefore, in this area, cosecant inverse x does not exist. That's why we restrict this area, so that cosecant inverse x is exist. Already I said so many branches are there, so that cosecant x is bijective, but we are considering only principal value branch here. the principal value branch is x belongs to closed interval of, just like sign, minus pi by 2 to plus pi by 2. But if x equal to 0, it is not defined. That's why we are excluded the element 0. So therefore, f domain closed interval of minus pi by 2 to plus pi by 2 except 0 to capital R minus open interval of minus 1 comma 1 comma, it is defined as f of x equal to cosecant x is bijective. Therefore, its inverse is exist in this area. Of course, it is a principal value branch. Okay. So therefore, f inverse is, what is its range? It will become domain or minus open interval of minus 1 comma 1 to closed interval of minus pi by 2 to plus pi by 2 except the element 0. F inverse of x, it is denoted by cosecant inverse x or arc arc cosecant x. Similarly, we have some beautiful formulae regarding this. So, cosecant inverse of x equal to theta, that by implies x equal to cosecant theta for all x belongs to, x means take inverse function, x means its domain, inverse function its domain is capital R, any real number except this area. Okay, in this area only it is possible. Next, cosecant inverse of cosecant theta is equal to theta, whereas theta belongs to closed interval of minus pi by 2 to plus pi by 2 except the element 0, and cosecant inverse x, that is equal x comma x belongs to cosecant inverse x. X is what capital R minus open interval of minus 1 comma plus 1. So we can show the failure cases and success cases as examples for these three statements. These are the important. So this is the synopsis or definition or concept of sin inverse x, cos inverse x, tan inverse x, cot inverse x, secant inverse x, cosecant inverse x. So therefore, in the restricted areas only, all trigonometric functions having their respective inverse functions. If out of restricted area, it is not bijective. That's why in actual domains, all trigonometric functions do not have their respective inverses. This is the lesson. Actually, how can we obtain or plotting the sin inverse x graph, sin inverse x graph, or cos inverse x graph, similarly cosecant inverse x graph? Two methods are there. By interchanging x and y axis, this is one method. Second method, by treating y equal to x as a mirror, we can obtain the sin inverse x graph with respect to y equal to sin x. So first we draw y equal to sin x graph and treating y equal to x as a mirror, then we shall obtain its sin inverse x graph. So what I am telling that by interchanging x and y graph, x and y axis, we can obtain inverse function graph. Second method, by taking y equal to x, the line means angle bisector line, as a mirror, we can obtain the inverse of the given original function.